Okay, fourth graders, today we're doing the last lesson of Module 5 because this Friday you are ready to take your Module 5 test. Okay, today we're doing Module 5, Lesson 41, and what we're going to be doing is we're going to be looking to see if we can find any patterns to help us as we add lots and lots of fractions together. Okay, but first let's talk about the problem of the day. It says Jackie's paper chain was 5 times as long as Sammy's. Whose paper chain is longer, Jackie's or Sammy's? So if I were to draw two paper chains, Jackie's would be longer than Sammy's. Do you guys agree? We know that Sammy's was 2 and 75 over 100, 75 hundredths meters. And Jackie's was 5 times as long. So that means Jackie's is 1, 2, 3, 4, 5 times as long. We want to find the total length of their chains. How do I find the length of Jackie's chains? 5 times 2 and 75 over 100, right? So I could add them up, or I could find out how, I could think to myself, how many units of 2 and 75 over 100 are there total? Everyone? 6. So I could do 6 times 2 and 75 over 100. Could I use the distributive property to help me do that? Yes or no? Yes. Anytime I'm multiplying a whole number by a mixed number, I can do that. I could do 6 times 2, which is 12, right? And then I could do 6 times 75 over 100. Now, I can't do, I know 12 is still 12. I can't do 6 times 75 in my head. But could I write it out using the standard algorithm? Yeah. So I have 75 times 6. What's 6 times 5, everyone? Okay. What's 6 times 7, everyone? Plus 3. So this is equal to 12 plus 450 over 100. What do we know about 450 over 100? That's really equal to 4 and 50 over 100. I have to add 12 to that. So altogether, what do we have? 16 and 50 over 100. Now, what would the units be? Meters, good. What do we know about 50 over 100? That's exactly what? So could I also write 16 and a half meters? Yes, I can. Very good. Today we're going to be working out of our problem set book, but we are not going to be skipping ahead. Okay, let's take a look at number 1a. It's telling us to find the sum. Okay, so we have 0 thirds plus 1 third plus 2 thirds plus 3 thirds. I notice right here, 0 is by itself, right? But I notice that 1 third plus 2 thirds equals 3 thirds. Do you guys know that? Notice that, right? And then similarly, 0 thirds plus 3 thirds also equals 3 thirds. So if I want to add this, it's kind of the same as adding 3 thirds plus 3 thirds. Do you guys see that, right? What does that equal? 6 thirds. What does that equal? Huh? 2. So what's the sum of 0 thirds plus 1 third plus 2 thirds plus 3 thirds, everyone? 2. For B, we're adding 0 fourths plus 1 fourth plus 2 fourths plus 3 fourths plus 4 fourths, right? So let's see if we can find those patterns again. I know that 0 fourths plus 4 fourths is 4 fourths, right? And then 1 fourth plus 3 fourths is also 4 fourths. Do you guys see that? Did I add up all the factors yet, or all the add-ins? I still have this 2 fourths, right? Is there anything to match that with to make it be 2 fourths? No. So I have to just write it. So I have 4 fourths plus 4 fourths plus 2 fourths. What does that equal? Well, I know this is 1, and this is 1. So I have 2 and 2 fourths. Do you guys see that? Let's compare what we noticed between the first one and the second one. The first one, what are we adding? Thirds. And how many different add-ins are we adding? 4. So each one kind of had a pair, right? For the second one, we're adding fourths. So we had 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths. How many add-ins are we adding? So could we make pairs with all of them? No, we could pair the first and last one, the second and second to last one, but then the third one, the middle one, is standing by itself. How does the middle one standing by itself affect the final answer? Our first answer was a whole number, 2, and our second one is mixed number, 2 and 2/4, or 2 and 1/2. Talk to your table group members. What do you notice? What patterns do you notice? You might be starting to think of some rules or some patterns. Let's see if we can confirm that they're true. For part C, we have fifths. So we're adding, let's see how many add-ins we're adding. 0 fifths, 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths. How many add-ins are we adding all together? 6 add-ins. Okay, so do we have an even number? Let's see if we can make pairs. I have 0 fifths plus 5 fifths. What does that equal? 5 fifths. Okay, and then my next one, I have 1 fifth plus 4 fifths. What does that equal? 5 fifths. Then I have 2 fifths plus 3 fifths. What does that equal?
5 fifths.
Huh. So I have 5 fifths plus 5 fifths plus 5 fifths. What does that equal? 3, right? So I had 6 add-ins, and I could make 3 pairs, and my answer is 3. Okay, let's take a look at part D. Now we're dealing with sixths. When I have sixths, how many add-ins will I have?
7.
Yeah, because I have 0, 1, 2, 3, 4, 5, 6. So that's 7. Do I have an even number? Am I going to be able to make pairs? No. So what does that mean for our answer? I'm thinking maybe it means we're not going to have just a whole number. Let's see what pairs we can make. I have 0, 6 plus 6, 6. What is that going to equal? 6, 6. I have 1 6 plus 5, 6. What's that going to equal? 6, 6. I have 2 6 plus 4, 6. What is that going to equal? Huh. I have 3 6 left over. So if I add these up, I have 6 6, 6 6, 6 6, and 3 6. This is 1, 2, 3, and 3 6 is exactly what? Half, huh? So this is going to be 3 and a half. Is it working with the pattern that you identified? Whenever we don't have enough to make a pair, what is the fraction always going to be? It looks like we're always left with half, because the middle number, 3 6 and 2/4, always seems to be exactly half. Huh, that's cool. Let's see if we can use our pattern. See if it still stands. Here I have sevenths. And how many terms will I have in my addition if I have sevenths? Everyone?
8.
Because we always start with 0. You might think sevenths, that's 7, but we have to add 0, so 8. So do we have enough to make a pair? Let's check it out. 0 and 7. What's that going to equal? 7, or 7 sevenths, or a version of 1, right? 1 seventh plus 6 sevenths is also going to be 1. 2 sevenths plus 5 sevenths is 7 sevenths, which is also 1. 3 sevenths plus 4 sevenths is 7 sevenths, which is equal to 1. So if I have 8 pairs of fractions, my answer is 4. Do you guys see that? Okay. Now let's take a look at the last example. Now I have eighths. How many terms do I have here? 9. What's going to be the one that doesn't have a pair in the middle? 4 eighths, right? Because if you look at the rest, 0 is going to pair with 8, 1 is going to pair with 7, 2 is going to pair with 6, and 3 is going to pair with 5 eighths. So we're going to have 1, 2, 3, 4, and 4 eighths, or 4 and a half. Does it still fit with the pattern that we noticed? Yes or no?
Yes.
Very good.